Hey math fans, we're on section 1.3.1. Let's get started. So what is a square root? Remember, a square root is a number when it's multiplied by itself, remember it's got to be the same number, equals the number inside the radical. For example, the square root of 36 is equal to 6 because positive 6 times positive 6 equals 36. However, there's another answer too. It could also be negative 6 because negative 6 times negative 6 will also be positive 6. So really the square root of 36 has two answers, positive or negative 6. Now, the problem becomes when there is a negative inside the radical, because if I try to take the square root of negative 1, well, how can you do that? Let's see here. I mean, the square root of positive 1 could be either positive 1, because positive 1 times positive 1 is positive 1, or the square root of positive 1 could be negative 1, because negative 1 times negative 1 equals positive 1. Remember, it's got to be the same number. So it's basically impossible to take the square root of negative 1. So the French mathematician René Descartes said, well, let's just call it an imaginary number, which is different from a real number. So it really is a square root of a negative number. Or in other words, we're just going to say that it's the square root of negative 1 is equal to this imaginary number, and we call it I. So anytime you see an I want you to think in the back of your mind that it's the square root of negative 1. Now, when you combine a real number with an imaginary, they call it a complex number. And sometimes a complex number can be wholly imaginary or wholly real. In other words, it's missing one of those parts. But together they call them a complex number. So here's another breakdown. You can have a real part, and then you can have the imaginary part. So I have some examples over here where 2 plus I, that's a complex number. You have a real component of 2 plus 1I, or I, which is its imaginary component. Or negative 3 plus 7I, or 6 minus 4I. Those are complex numbers together, but it has a real part and an imaginary part. So if I is equal to the square root of negative 1, what would I squared be? Well, it would be the square root of negative 1 times the square root of negative 1, which would be the square root of negative 1, all of it squared, which is just going to be negative 1. Okay, so I squared is equal to negative 1. Well, how about I to the third? Well, I to the third would just be I squared times I. And we already said that I squared is negative 1. So negative 1 times I. So I to the third is going to simplify to the opposite of I, or negative I. Well, what about I to the fourth? Well, I squared is negative 1. So it's like I squared times I squared, which is just negative 1 times negative 1. You get positive 1. Interesting. Well, what about I to the fifth? What about I to the sixth? Well, I to the fifth is I to the fourth times just I to the first, which is, remember, I to the fourth is 1 from the previous problem. So it's 1 times I, which is I. Okay. What about I to the sixth? Well, you get I to the fourth times I squared, which is 1 times negative 1. And I got negative 1. Well, it doesn't take long to realize there's a pattern going on here. Does anyone see the pattern yet? Basically, it occurs every fourth power, the pattern repeats. So when you get to I to the fifth, you're back to I to the sixth is negative 1, I to the seventh is negative I, and then you go to I to the eighth. Well, that's like 2 I to the fourths, which is just 1. You're going to end up with 1 again. And then I to the ninth is I to the 10th is negative 1, I to the 11th is the opposite of I, and it keeps going. It repeats every fourth power. So a quick way to figure out what it will simplify to is you can divide the exponent by 4, and whatever remainder you have left over is really going to be that answer to the final simplification of I. So if it has a remainder of 1, it's just going to be I to the 1. If it has a remainder of 2, it's going to be, well, I squared, which is actually equal to -1. So we're really just looking at that remainder. And then remember, if it's a remainder of 0, then it's just going to be 1. All right, so for example, I to the 57th power, how are we going to simplify this? Well, you take 57, you divide it by 4, you get, 14.25 from your calculator. But remember, that's really like saying 25 over 100, which really means it's a remainder of 1 out of 4, which means it simplifies. I to the 57th power simplifies to I to the 1, which is just I. Again, your book outlines if it has a remainder of 0, a remainder of 1, remainder of 2, remainder of 3, what it will simplify to. Keep in mind, I to the 0 is really equal to 1. So if it has no remainder, it's going to be 1. And of course, just remember that I is the square root of -1. Here's some common errors and misconceptions. Example 1. Identify the real and imaginary parts of the complex number 8 plus 1/3 I. Remember, the real component comes first, so the real number here is going to be 8. And then the second part, the imaginary part, is going to be 1/3 I. So it's got a real and imaginary component to this complex number. Example 2, rewrite the complex number 2i using a radical. Remember, I is equal to the square root of -1, so we can substitute the square root of -1 in for I. And then we multiply, and we will get 2 squared in the radical, because once it goes inside the radical, remember, you're doing the opposite. So if it leaves the radical, you're taking the square root. If you're putting a number inside the radical, like we're doing here, you're actually going to square it. So 2 squared is 4, and you're going to end up with the square root of -4. Most of the time, we're going to be doing examples or problems like example 3 here, which says rewrite the radical square root of -32 with the imaginary unit I. So step 1 is to identify that square root of -1, and there it is. And we're not going to be able to simplify that other than make it an I. So square root of -1 is I. But we're still left with I times the square root of 32. And if you remember, I taught you guys how to simplify radicals. We were looking for a perfect square, which 32 is really 16 times 2. So the square root of 16 is 4. That gets to stay on the outside now with the I. So your final answer is going to be 2i radical 2. And example 5 talks about impedance. And here's a good real-life example of where imaginary numbers can be used. Impedance Z is the measure of a circuit's opposition to the flow of current, and complex numbers are used to represent the impedance of a circuit. So the resistance R is the real part, and then you have the reactance X, which is really the coefficient of the imaginary unit I. So for this particular problem, we can identify those parts there. So the resistance is 18, so the real number will be 18, and then the reactance is 2, so that'll be 2i for that imaginary component. So we could write it as 18 plus 2i. And that's going to do it for this section. We'll see you in class.